Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to take a look at how we can produce a monostable using LM555. If you look at the datasheet LM555, there is a description about monostable operation using LM555 because we can produce monostable with for example some bipolar transistors. Okay, but this video is just about using LM555 to show monostable. Okay, monostable, what is a monostable? It's it has one state, one pulse in the output, and you had to know what is inside this LM555. Okay, before I'm moving to the simulation, let me just take a look at this circuit and what is happening inside this circuit in order to produce a one-shot pulse in the output. Okay, here this is a trigger. This is a trigger pin, and if this V trigger if this V trigger is less than VCC divided by 3, the output voltage V out is going to be high. High means VCC in here. Okay, and if that's not the case, which means that V trigger is not less than VCC divided by 3, you had to check this threshold voltage, V threshold, and if this V threshold is greater than 2 divided by 3 times VCC, V out is low. So these two pins, I mean number 2 and number 6, in LM555 is really critical to producing monostable and even astable in the output waveform. And this is the output pin, pin 3. Okay, you had to know all of these pins. Actually 8 is a VCC pin, 4 is a reset. Reset had to be in high in order to work this circuit. If this reset is low, it's not operate. And the 5 is just control voltage, 1 is GND, so you have to connect it to the ground. Okay, this is the main idea to produce monostable. Now take a look at our simulation setup. As you can see, this is connected to the ground. This is output. I just connected to some load, 100 kilo ohm. This is a reset pin which is connected to the VCC. Our VCC is 12 volts. This is a control voltage connected to 10 nanofarad capacitor. This is a VCC connected to VCC, which is 12 volt. And this discharge and threshold are connected together, both with the 1 kilo ohm resistor to the VCC and 100 nanofarad to the ground. And the time constant of this RC, it shows how much time it takes for this node to become greater than 2 divided by 3 VCC. This is a node, this is pin 6 and this is pin 2. But in order to see how it operates in LTspice, I choose a PWL waveform, and if I run this simulation, you can take a look at this waveform in the trig part to see all different options. You see, first it is just 12 volts, and then it decreases to the 0 in 5 milliseconds. So during this time, it will definitely see the voltage around 4 volt. You see, this is when it becomes 4 volt. Why 4 is important? 4 is actually VCC divided by 3. Remember, VCC is 12, so VCC divided by 3 is 4 volt. This is where the output becomes high. We expected that the output become high in this time. Okay? And at the same time, we had to see what happens in this DIS node in here, which is a threshold node as well, and see when it becomes greater than 2 divided by 3 times VCC, which is 8 volt in here, but on that time the trigger must be high or greater than VCC divided by 3 to operate. So now again, see this voltage. Before I'm going to look at the output voltage, I want you to understand the whole idea, the whole concepts behind this. It is really important to become a great electrical engineer. You have to analyze it by yourself. So now I want you to take a look at this, and based on this information, this waveform of trig and DVDs, and based on this information that I was give you, predict that what is going to be your output waveform. Okay, now here again hit C, and you can see here it becomes this is where our trig equals to 4 volt. Okay, and of course the VDs is equal to 8 volt in almost in here, but the thing is, during this time the trig voltage is not high, is still less than VCC divided by 3. So V out is not going to be 0. V out is still high until this V trig becomes high. This is what we have expected. Between almost this time and this time is when the output is high, and other than this the output is low. So now we're going to take a look at V out. This is as we expected. You see here V output is become high, and then here it becomes low here because V trig is less than VCC divided by 3, and here VDs is become higher than 2 divided by 3 times VCC. Here the 4 volt is our comparison, and here we compare it with 8 volt. So this is the waveform of output, and you can see it in above this. You can take a look at it, and this is when V out becomes high during this time. So the width of this V out is defined by when the V trig is less than VCC divided by 3, and when VDs is higher than 2 divided by 3 times VCC. Okay, and the time constant for this node to become higher than 8 volt is defined by this RC. Okay, this is what I was going to tell you about this, how to create monostable in LM555. I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. I will see you in the next video. Thanks for watching.